Okay, so if you remember from Greenbelt, we had a roadmap for doing the project storyboard, and we're going to recreate that. But I want to highlight the tools that we're going to use in Minitab, and this will also then begin to bring up the hypothesis test that you're going to learn. Now, you'll learn some more advanced hypothesis tests during that course as well, but they don't go up on the roadmap. They're things that you would use as needed. All right, so if you recall the define phase, so this is define. We had our slides. We had the cover slide. You had the business case, which is why is this project important? So you had the problem and the goal. So let's pretend greets did matter. The problem is the greet score is 45 on average, and our goal is to get it to 80. The business case would be the greets drive sales. We know that didn't happen, but we're playing pretend, right? So we would talk about the impact of sales. But the next slide, you know me, the most important thing is this slide right here. What is the definition of a greet? What is the definition of the greet score? So that's the operational definition. What is the definition of a handshake, sweetheart? What is the definition of a kiss per day? What's the definition of a good truck? What's the definition of a good MBA? All right, so then measure is where things are going to start to change using the Minitab software. Now for discrete, it's going to pretty much be the same. If you recall, we did DPO, DPMO, sigma, and yield. All right, we did that freehand using my template in Excel. You would still do that. And we would still do the Pareto. Now in Minitab, that is either, these are the drop downs, stat, Pareto, or assistant. There's this cool feature called the assistant, and under there is the Pareto. All right, so that's where that would be. Again, the hypothesis is still the same with Pareto chart. Do we have is something causing most of our defects? Now, measure phase. We did the histogram. And that's under stat, basic stats. And it's called in Minitab the graphical, I'll tell you what, let me turn this way, I'm right-handed. Graphical summary. Now that also can be found with this cool feature in Minitab under the assistant. All right, so either way, it's going to give us everything that my Excel template did, except we had to do multiple steps, if you recall. It's going to give our basic statistics, our histogram. It's going to tell us if our data is normal, right? Which, if you recall, that helped us determine if we have to use the mean or the median for the problem and goal. Then you have capability, which is, that example. Here's an upper spec limit. Here's the percent that's bad. That gave you your sigma. Okay, that is in a couple places in Minitab. Under the assistant is really easy. And it's also under stat quality tools. All right, so those are a couple places where you can do that. The stat, what I'm literally saying is you go to Minitab, go to the stat drop down, click quality tools, and then you'll see the capability analysis. This was sort of the old way of doing things before the assistant came along, and they each have their own sort of positive and negative. Finally, you have, if you recall, your control chart, right? It would draw a line at plus or minus 3 standard deviations and tell you if your process is stable or out of control. That's a hypothesis, by the way. So normal data is a hypothesis. We want a p-value less than 0.05 to say our data isn't normal. And in Minitab, and even in my Excel spreadsheet, it would label special cause, if you had special cause variation. The null hypothesis is you have no trends. The alternative is you do, as an example. And this is under stat, stat, control charts. Or you guessed it, the assistant, control charts. Now I like it under the assistant because it has a really nice roadmap in there that you can, like, what type's your data? Continuous. Okay, and then it takes you to the next screen. Do you have one group, 5 groups, 10 groups, subgroups? So this is a really cool feature there. So again, the null hypothesis is nothing's going on. So that's the measure phase hypothesis, okay? I tell you what, let me pause here so you have this on a video, and then we'll do analyze. You want to just keep going? We'll edit it.
So, sorry, real quick, you want to pause? You're intending that we would pause? So
pause and then just call this analyze phase, or a roadmap continued.
Yeah.
I want them to be able to see this before, and not before I erase it.
Yeah, why don't you?
So that we've done that.
Yeah. Okay. All right.
You know what I'm saying? Just when you watch this, just
seconds, and then we'll move on.
Yeah, they can snapshot it or whatever.
Great.
All right. So 3, 2, 1. All right. So the analyze phase is the same. All right, except I'm going to add the Minitab. All right. So if you remember, we had the process door. So folks that say that Lean Six Sigma is process improvement, they're saying this is the only door you can go through, and they're also saying you have to go through that in the measure phase. And we had value stream map, very powerful tool, my favorite, value added, non-value added analysis. And then we had our other ad hoc lean tools, all sorts of lean terms. We talked about bottlenecks and takt time, and you've got the spaghetti diagram and all sorts of stuff like that. So the data door, if you recall, we have the data door. And what was our roadmap? Well, was your Y continuous or discrete? If it's discrete, it was another Pareto. All right, so now, what are the hypothesis tests when you have a discrete Y and a discrete X? They're called chi-squared. Chi-squared. And that's another country song. And chi-squared is the tool that you use. It sort of sounds like the R-squared song. So chi-squared, you have goodness of fit. That's the nurse example. That's, I don't know, I'm doing a course on a religious campus, right? And I know that 50% of those that profess Christianity in the United States identify with the Baptist denomination. And I'm in my classroom and I say, raise your hand if you're Baptist, and 10 out of the 20 students raise their hand. I'm going to go ahead and say that what I see in my classroom fits the expected distribution. Okay, so that's the goodness of fit. And then you have test for association. All right, that is, that would be like 13% of the population in America is African American. Let's say 40% is white, 20% is Hispanic. And I have a class of 30 people, and I have 10 African Americans, 10 Caucasians, and 10 Hispanic people. Does what I see in the classroom associate with that, or do I have a disproportionate amount of one group? Okay, so that's the test for association. Both of these are under, as you guessed it, stat, and then it's called tables, and then you would see these two options, okay? Yeah, that would be that. And then, of course, you can also do a 1 proportions test and a 2 proportion. Example of a 1 proportion. They're kind of the same. They both kind of do the same thing. I'm going to run for office if 60% of my neighbors want me to run. Well, I can't talk to everyone that lives in my neighborhood. Remember, statistics, the assumption is I can't talk to the population. I have this population. So I have to take a sample of the population, and I'm going to use that. I mean, if you're dealing with all the data, you don't have a sample. You don't use statistics. The Bob makes more than Sally because I have all of their sales data. There's no need for statistics. We assume we're dealing with samples, but I'm only going to run for office if 60% of my neighbors say they'd vote for me. We do a sample of 100 people in my community, and let's say 55% say they would and 45 say they wouldn't. Well, look, it's statistics. Does 55 equal 65? And when you're dealing with a sample size, a margin of error, the answer is yes. 55 could equal 65. That's the old joke. You go into the boss's room and he says, what's 2 plus 2? The mathematician says 4. Then he calls the accountant in the room. He says, what's 2 plus 2? He says 4, give or take a little bit. Then he calls the statistician in the room, says, what's 2 plus 2? He looks around, closes the windows, and says, what do you want it to be? So, but remember, if you've got a population of 10,000 people in your, I'm thinking the Nextdoor app. When I say neighbors, I'm thinking this Nextdoor app where you've got 20 communities. I talk to 100. This might be equal, all right? Now, is my X continuous or discrete? So continuous Y, continuous X. That's the scatter plot. And you guessed it, that's either under graphs, that's a drop down in Minitab, or it's under the assistant. All right, and this is a hypothesis test. This was the one that said, if you remember my greets and sales, my greets and sales actually look like that. There was no relationship. The hypothesis test is regression. All right, and then, the null hypothesis I already told you was the X does not predict the Y. The regression's a little confusing because you don't assume the relationship. So sometimes you have to make an extreme example. Does the price of tea in China today predict the price of a gallon of gas in America tomorrow? No, that's the alternative hypothesis, okay? I'm sorry. No, that's the null hypothesis. Yes, you would not assume any relationship. The alternative is that it does. That's what you're trying to prove. Ooh, almost messed that up. That's under stat regression or the assistant. All right, and then finally we have a continuous Y, discrete X. That was our favorite tool in Greenbelt, or at least mine, the box plot. And that also is either under graphs or the assistant. So I'm going to point a little arrow there. And then your hypothesis tests are the t-test. Is Bob's average sales equal to 200? The two-sample t-test. Do Bob and Sarah have the same sales? The ANOVA. Do Bob, Sarah, and Lee have the same sales? Now, these all compare averages. If your data is not normal, what did we do in Greenbelt? We compared medians. You can do the same thing here. All of these tests have a test like it under non-parametrics. Okay, so you go stat, non-parametrics, and every test we do on averages, we can do on medians. And so let me give you that real quick so that you're not left in the dark. I'll delete that. And this is all on an Excel spreadsheet I'm going to give you as well, but the t-test would be the Man-Whitney would be the two-sample t-test. And instead of comparing averages, it would compare medians. The one sample, you got to love these stats guys naming everything after themselves. Wilcoxon. Whoa. Okay, what did I do? There we go. All right.
Oh, your wrist is touching it. Sorry.
Is the one sample t-test. Is Bob's median sales equal to 200? Do Bob and Sarah have the same median sales? And then Moods, median. All right. Do Bob, Lee, and Sarah have the same sales? Okay. All of these are located under stat. And then you can go in, the one sample is under basic stats, and so is the two sample, so that would be the 1 and the 2. Under stat, ANOVA would be the ANOVA, and then under stat, non-parametrics would be all of these. And Under the assistant, you can do these, but you can't do the median. So for whatever reason, I don't know why Minitab decided that. But that's basically, now we're not saying your project requires a hypothesis test, but your job as a black belt is to know which one to pick. Again, I'm never going to do freehand calculation of statistics with you because that's not what I expect of a business person. But I expect a business person to know, let's do one quick example, that plant 1 made 100 widgets and 25 were bad. Plant 2 made 180 widgets. Let's say they have a larger production and 45 were bad. Who should I work on for my Lean Six Sigma project? Okay, well, I have plant 1, plant 2, that's discrete. Good, bad, that's discrete. I have 2 of them. It's the chi-squared test for association. Is there any association between plant and defects? And the null is no. And the alternative is yes. And if we get a p-value of, let's say, 0.082, we accept the null. Both plants, based on the proportion that they're making, are also making the same proportion of defects. So if I was hoping as a black belt to focus on one plant, this says I have to focus on both. Now, you may still focus on one just from, remember, plant 1 might be a VP that wants to work with me, and I want to show some success. So now that I know that both are equal, like my boss might have said, hey, you got to go to plant 2, they're making more defects. And I go, hey, statistically, they're making the same amount of defects, and I'm going to go to plant 1 because he really wants to work with us, and this will give us an opportunity to show some early success. So that's your roadmap, and we're going to be doing some exercises throughout the semester where I'll ask you to pick the correct test, analyze it, and give me the appropriate answer. See you there.